Kirchhoff's law of electrical network. Now here, so basically here there are two Kirchhoff's law. The first one is Kirchhoff's first law. It is called as Kirchhoff's current law. It is also called as Kirchhoff's junction law. Now, what is the Kirchhoff's current law? Or in short, it is abbreviated as a KCL. Now, let I tell you the statement for this. Mathematically, the Kirchhoff's law is summation of I is equal to 0. Now here, basically, summation of I is equal to 0. But which summation we have to take? That is very important. So this is a junction law. So we are considering a junction. So algebraic sum of current at any junction is equal to 0. So this is algebraic sum. This is current at any junction is equal to 0. This is a statement for Kirchhoff's current law. Now let I explain this Kirchhoff's law with a simple example. Before that, let I display here its statement. You can see here the statement. Now junction means, everyone knows junction means what? Junction means it's a common word, common terminal, common point means the junction. Now here, so to explain this Kirchhoff's law, we require sign convention. Now what is the sign convention here? So two sign conventions are there. Out of that, one sign convention is about incoming current to the junction. The current coming inside the junction or entering the junction, you remember it is positive. And second one is current leaving the junction or outgoing current. So outgoing current is or are negative. Outgoing currents are negative. Now, let I explain with a simple example. Now see here. So you can see this current I1 and current I4. These two currents are entering this junction. This is junction. Junction means common point. And leaving current you can see here. I2, I3 and I5. These are the leaving current. So you can see the direction of the arrows. And this is junction. So this is a junction. Junction means common point. Now here by Kirchhoff's law, current entering the junction positive and the leaving current are negative. Means I1 positive, I4 positive because they are entering, I2 negative because it is leaving current, I3 leaving current and I5 leaving current. So if I apply here summation of current is equal to 0, then by Kirchhoff's current law we can write. So this I1, I can write I1 here because it is positive. Then I2 is negative, so minus I2. I3 is also negative, minus I3. I4 is positive, so plus I4. And I5 negative, so minus I5 is equal to 0. So this is the equation by using Kirchhoff's law. The same equation we can write by rearranging the term. Whatever the negative terms are there, these negative terms we are shifted to this right hand side. So we get a equation I1 plus I4 is equal to I2 plus I3 plus I5. Now you can see here I1 plus I4. This is total entering current. So you can see here I1 is entering the junction and I4 is also entering. So total entering current. And this I2 plus I3 plus I5, if we add these three, the leaving current, so we get total leaving current. So in simple word, we can write current entering the junction is equal to current leaving the junction. So alternately, you can write a statement of the Kirchhoff's current law. Current entering the junction is equal to the current leaving the junction. So if you are written statement in that way also, then it is also a correct statement. So basically you remember here, so Kirchhoff's current law is related to the current. So this law is related to the conservation of charge. The second Kirchhoff's law is Kirchhoff's voltage law. So it is abbreviated as KVL, Kirchhoff's voltage law. Now, Kirchhoff's voltage law. What is Kirchhoff's voltage law? Now you can see here the statement you have to see first. So this is statement. Summation of IR plus summation of E is equal to 0. Now here you know that by Ohm's law V is equal to IR. So IR means the potential. This IR means potential. So algebraic sum, you can see here, algebraic sum of potential difference. Okay, potential difference, or you can write product of current and resistance, but you can write only the algebraic sum of potential difference. And electromotive force, this E, you can write capital E also for this electromotive force. Summation of E means algebraic sum of this electromotive force in a closed loop. This law is applicable to the closed loop. So previous one is the junction law, this is the loop law. So algebraic sum of, when you are writing a statement, you have to remember this algebraic sum of this potential difference and electromotive force, or you, in short, you can write EMF in a closed loop is equal to 0. So this is the Kirchhoff's voltage law. Now to explain this Kirchhoff's voltage law, we require sign convention. Now let's see sign convention. Now sign convention, first sign convention. So here the loop tracing direction is very important. Now what is the loop tracing direction, that I will explain later. But so here if we are tracing loop along the direction of current, listen, this is very important word, along the direction of current, potential difference negative. So potential difference is negative when we are tracing loop in a direction of current, then potential difference is negative. Otherwise it is positive. The same thing is written against the direction of current, it is positive. If we are tracing a loop against the direction of this conventional current, then this potential difference is, or potential difference, whatever the potential difference are there, they are positive. Means along the direction negative and against the direction positive, that you remember. So this is sign convention about this part. Now sign convention about EMF, second sign convention you can see. So EMF positive. Now see here, when it is positive, when we are tracing loop within the source, this is where very important, within the source, negative to positive, means this is the battery, this is a plus terminal, this is minus terminal, and we are tracing the loop negative to positive, means in this direction, inside the loop, inside the battery, negative to positive, means if we are tracing towards the positive, then it is positive. This is a sign convention. Now the EMF again negative, when it is negative, when we are tracing a loop within the source, positive to negative, means this is a positive and this is negative, and we are tracing loop positive to negative inside the cell, then it is negative, means towards the negative inside the cell, negative, towards the positive inside the cell, positive, that you note. Consider an electrical network as shown below. So you can see electrical network here. So E1 is the EMF source 1, E2 is the EMF source 2, R1, R2, R3, these are the resistances. Now we name this loop as a B, C and D. Now let me consider the direction of the current. Current sent by a battery E1, we named it as a I1. So current flows from positive to negative. Current sent by battery with the EMF E2 is I2. Now after that, you can see a direction of I1 and I2 here. So this is I1. Now here this is I2 and this is I1. They mix and here we get I1 plus I2. So moving along this branch AC. Now here, so this current I1 plus I2 is here, and here this, where at point C they are separated, and this current I2 is moving through this CD and I1 is going in upward direction. Now we have to apply Kirchhoff's voltage law to this diagram. Now after applying a Kirchhoff's law, to this loop. You can see this name of the loop A, B, C, A. So for a loop A, B, C, A, you can see here, this is a loop A, B, C, A. Now how to write down equation for that? Now you know that by Kirchhoff's voltage law, summation of IR plus summation of E is equal to 0. Now let me start from A. Now as I start from A, we have to trace the loop in this direction. You can see the loop trace direction. You can select any direction for the loop trace. Now we are selected like this A, B, C, A. Now this is the EMF source E1. Now we are tracing this loop inside the battery from positive to negative. So towards the negative, so EMF source is negative. So you can see minus E1 here. Then here the current is I1. So this I1 into this R1. So you know that current is like this. So this is the current I1 and this is current I1. So we are going A to B and current is coming B to A. So here this I1 R1 is positive. Then we are coming to this branch CA. Now in that, so this resistance is R2 and current flowing through this is I1 plus I2. So this current multiplied by the resistance. So I1 plus I2 into R2 and it having a positive sign because we are going upward direction. The direction of the loop trace is in C to A and the current is A to C. So here the positive and is equal to 0. So this is a equation by Kirchhoff's voltage law. Similar manner, we can apply it to a loop A, C, D, A. You can see here A, C, D, and again A. Now when we are going from A to C, so this is I1 plus I2 and this R2. Now here we are going in a direction of current, so minus sign to this. So when we are going opposite direction to the direction of the current, that time plus sign. Now I2 and this R3. I2, R3. We are going in a direction of the current, so minus sign. Then this is a battery. So we are going like this in this direction. So inside the cell, negative to positive. So towards the positive, so E2 having a positive symbol. So this is the equation. You can see the same equation here.